Hi everyone and welcome to the videos on the product rule. Now, product rule, you can see I've written two different ways of expressing it here. So the first way using Leibniz notation, dy dx equals u dv dx plus v du dx. And look, this is a rule which you need to have committed to memory because it is quite important and it's used fairly extensively, particularly in exams. This is the other way of writing it. I tend to avoid this notation where possible. It's just not my preference, but that is another way that you can express it as well. And it's completely up to you which way you choose to do this. So the product rule, product means multiply. So this is used when we have two functions multiplied together. And you can see that in the three examples that I've listed just below. You can see that there is one function here multiplied by another function here. In the past, we could have dealt with questions like this by expanding out the brackets, but this gives us an all-round more efficient way of doing it. And here we can see in the second one we have the exponential function multiplied by the sine function, and likewise in the third one we've got the cos function multiplied by the square root function. So three different situations. It's probably going to take me a couple of videos to actually get through all of these because they are fairly involved, but well, we'll see how we go. Now, you'll see here when I use u and v, we haven't really encountered those yet, at least not the v. But when we're doing this, u is always the first function and v is always the second function. So in this case, u equals 2x plus 5. And v equals 4x squared minus 3 to the power of 2. So I can differentiate both of these. The first one gives me du dx, which is just 2, and the second one gives dv dx, which, using the chain rule, or perhaps making it a bit easier, the 2 is going to move down the front, leaves 4x squared minus 3, but then we need to multiply by the derivative of the inner function, which is just 8x. So I'm going to make that look a little bit nicer. That's going to be equal to 16x out the front of 4x squared minus 3. So the last thing I have to do is I have to get dy dx, which is u dv dx plus v du dx. I might go into a proof of why this rule is the way it is later on, but I'd say it's not particularly important to know that at this point in time. So the u is 2x plus 5, dv dx is that mess, 16x out the front of 4x squared minus 3, then plus v, which is 4x squared minus 3 squared, multiplied by du dx, which is just 2. So the last thing to do is to neaten it up a bit, and honestly I wouldn't be neatening it up a lot. This is something that is referred to as additional engagement and often leads to people losing marks. Now you'll probably find that the textbook will have answers which are different to the ones that you might arrive at, and what I'd suggest is using the verify strip to check that your answer is the same as the book. So in the end, the way that I'd write this, I'd write the 16x out the front, then the 2x plus 5, and then the 4x squared minus 3. And then I'll write plus, and I'll just put this 2 at the front as well. So I've got 2 at the front of 4x squared minus 3 all squared. And I would leave that right there. There's no need to go any further, though you could take out a common factor or something if you chose to. Right, I'm going to leave this video here and we'll pick up with the second example shortly.